Who will be first today? Jerry beat Cyber Bob? Or will Cyber Bob beat Jerry? Drone Shots is first. How are you doing? Oh, why does this take so long? Come on. Oh, why does this take so long? 3D Medic. How are you doing, Vince? Is the measurements? Oh man, I know one of these has them. Come on. One of these has the measurements. Saw it. So I gotta open up a bunch of them, huh? If I find one with the numbers. Yeah, we have a couple days of cold here, but then it's going to go back up to 50, 30. A little bit better. Yeah, it's 35 degrees right now. But starting Wednesday, we'll go back to roughly 50 degrees and 35 degrees. Yeah, 53, 38, 52, 39, 53, 32, and 54, 35, 55, 33, 51, 31. Right on the edge. I grabbed two of these boards to play with. These have they are lithium iron phosphate compatible, 1S compatible, and they do bi-directional 22.5 watt, which is fine for 99% of things. But I need dimensions. There it is. There's some dimensions. I knew there was one of these available. Take a screenshot. Do. Oh, interesting. Five, 10. At these? Have one with the. That's the one I want right there. Okay, that only has the dimensions of the holes. Oh, here's the overall dimensions. 42.5 millimeter. So it's a truncated circle? Shit, that's going to make it hard. But I think I can work with that. Hey, radioactive scalar, see? Okay. Where the hell's the cursor? There it is. I hate when I can't find the cursor. Sometimes it's so hard to see. That cut to there. Oh, I can't modify it? Huh? I can't alter the bounding box? That's annoying. I'll have to crop it first, I guess. That I'm pretty sure I can modify. Yeah. This. There. This one's going to be hard because you can't see it. Pretty sure it's right about there. Okay. Oh yeah. Well, no, I need these. Um, what I need is to create a circle first. So I can eliminate everything outside the circle. I don't think it's going to let me do that. Because I have to approximate it. Can I drag this? Yes, I can. I wish there was a way I could resize it. Is there no way for me to scale this? That's what I really need. I need to rescale the circle I just made, but I don't think there's any way to do that. Oh, I see what you mean. I don't need to use this shot for the edit. I see what you mean. Mm-hmm. Yeah, you good point. This is a lot easier. Screenshot. Yeah, good point. Hey, Cyberbob, how are you doing? Okay. How do I align them? Okay, so I can grab this, but that doesn't do me much good. Okay, that gets the shape correct. Okay. Okay. Not what I wanted. Mm. This. Here. This one. Okay. I can ignore that. That's the button anyway. Here. Okay. Select inverse. Now we want to deselect these. Okay. Select inverse again. Hear it. Okay. Select. Now how do I get the other half in here? Guess I need this one so it's the same scale. So now they're the same scale. Select. Select inverse. Can I just drag this over to here? Yes. I was wondering if I could do that. Oh, so they're not scaled properly. You look at that. And I can't rescale this. So that tells me I need to bring it over here. And that's not going back. That is. So these are not scaled correctly. Not what I wanted. Absolutely not what I wanted to do. Let's go deselect. interesting. They're slightly rotated. Hey, Cassandra. I did not realize that would be a problem. I don't want to scale it. What I want to do is rotate it. There it is. Still need to rotate. Boy, it's not even close. Damn. There we go. Okay. Getting closer. And of course it's jumping. There's a distance. If you're within a certain distance of the edge, it jumps to the edge. Oh, for Christ's sake. Why has it gotta fuck with me? There. Now I have more wiggle room. What's it still jumping for? Like, what the hell is it jumping to? There we go. That's pretty close. Hmm. Oh, I can't reselect. Unless it's on here. Yeah, that's gone. That's okay, though. I can just do this. Screw you. Now I can do this. Edit, clear. There we go. Now I don't need this anymore. Okay. Nope, I do need that still. Select. Inverse. Okay. Now what I need to do is I need to chop out a chunk for the USB port. Wrong one. I want this one. Need to chop out a chunk for this USB port. Need to demarcate a location for this LCD. Okay. I should be able to clear again. Nope. Inverse. Here. Okay. Inverse again. Okay. Then we do a crop. Okay. Save as PNG. Okay, 22.5 watt board. That is so not what I want. How many times do I have to hit that letter? Okay. I ordered 2 of these boards, so we'll see if they're any good. There was one with more dimensions. That only has the holes. What am I looking at? Oh. I thought there was one that had better dimensions. Maybe not. I'm just opening up a whole bunch of them. So that's 43. That's including the USB port. So is that. I plan to stick 2 of these in one unit, so I can have dual 22.5 watt ports. And I might eventually stick 4 of them in one unit and use 2 batteries. So a 2S configuration. That way I can have 4 22.5 watt full speed ports. But there's I'll have one of them with that display on it, then get the one without the display for the rest of them, since I won't need the LCD display. But there's no cost difference. Actually, it's cheaper with the display. More dimensions. There. There. Now, is that pass through? No, it sits right on top of the board. There's some numbers. That's the same exact numbers. And that's the same numbers as well. Okay. Do PNG to CD. I'm hoping one of these days these companies will start providing 3D models of these boards that we can then import into whatever software we want to be able to make object to do this. Make life a lot easier. Hey, SPC. Alrighty, import. Okay, then we take this, we make it 42.5. Not what I asked you to do. Why did you ignore me? I mean, why would you go away? Okay. Right? That should be pretty damn close to exactly how big this board is. Now, which side is the switch on? Okay, so I have it the correct orientation. So north is the USB-A, east is the USB-C. Is there a 3D models of mount components? Not interested in AI mode. Hey, Michelle. Okay, that's not very useful to me. That's worthless, actually. How about we try SMT USB-C? No, that's useless. How about USB-C female? There it is. Now we're going to do USB-A female. And there it is. Holy cow. This is all I need. A whole download. All right, now what is that? Is that a transistor or transformer? 2R2. That didn't help. I need the word for what that is. That a transformer? No. What is SMC 2R2? Yeah. It's an inductor. Well, that doesn't help very much. They're all different dimensions. Okay. Well, I got those models at least. Let's get them in here. Well, first, how thick is this board? It's got to be at least 3 millimeters thick. That looks too thick. I don't know. I don't know how thick that is. I also wish I knew what button that was. Although I have the scale. That right there is the tip of the button. Let's fill this in. I'll put you here. Bring you back here. Make you 2.9. Oh, that is so not what I wanted. Yes, it is. Drop. That'll work. You here. You there. Okay. So that's where the USB-A port goes. Drop. Oh my god, I keep missing the goddamn hitbox. Okay. This. This. Okay. That's where the USB-C port goes. Now what I need to do is put this in here. Up a little bit. Control D. Make you hollow. When you with this. Then make sure we're on the floor. This will be the display screen. It's probably not the right thickness, but that's okay. So now we have a model of the board, approximately. Now we bring in the components that are important. Hopefully it's already scaled correctly. Ender's right here. Should be able to see him on the bed. Yeah, right there. Noel is somewhere else. There it is. Okay. I'm going to make this real easy. I'm going to chop off the feet. Okay. Just do this. Then we do this. Then we put a floor here. Drop. Okay. It's probably centered. Oh, I guess it's not centered. Let's just do this. This. There. There. Drop. All right. That's the USB-C port. Right. Import to USB-A. Okay. Same silliness. Just gonna drop a block. Chop off the bottom. Actually, it's like we're not gonna chop the bottom of this off though. I think I need that part. I'm gonna go to here. Go to here. Drop it. You were gonna go roughly here. That's close enough. That's pretty close. Okay. All right. That is going to be the approximate board. So I need to make sure I can pinch this in place. I guess the reality is I need a box this shape. Because this is way complicated. All right. Drop you there. You are 14 by 14.2. 14 by 14.2. Damn. By 6.9. There we go. You and you are going to line up on you. Okay. Hide you. Delete you. Bring you back. Right? There's our USB-C port. Or USB-A port. Alright, this one's a little more complicated. I think I can still do it. Alright, so this is 8.94 by 7.8. 8.94. What did I say? 7.8? 8. Yep. By 3.16. 3.16. Not what I wanted to do. 8 by 3.16. Okay. Now, going to add radius. You and you. Line on you. Here. Here. Okay. And we're going to add that radius until we get the desired shape. Right there. Let's go 1.4. 1.35. 0.3. 2. 1.2. Okay. Now, put you here. Chop off this much. Then we Control D. Invert it. Chop off this much. Got the red one. You and you. I selected you. Okay. And 3.16. I guess. Oh, it's bigger. It's 7.8. 7.8. Align. Ignored the fact that I pressed the shift key again. You're an asshole. Okay. Then we delete. There. Now we have a simplified USB-A and a simplified USB-C. Now what I think I could do, I think it's as simple as stretch this out. And stretch this out. And that should punch through the walls. Now I can join them. Yeah, I think that'll be simple enough. Okay. Yeah. So Control D, make 2 of these. I could just delete these off this one. So this one will allow me to position in center. And then once I'm positioned and centered, and I create the cutout for this, I can then position this one and create the cutouts through the walls. Only problem is, I don't know if the PCB is actually 3 millimeters thick. I don't know how thick this PCB is. How do I know? And it's not giving me a side view. With a side view, I could figure it out by using the known dimensions of another component. But without, that's the closest I want to get to a side view right there. Oh, that's a naked USB port. So I got to change that too. That's easy enough to do though. Let's go import again. This file. Let's be type A. Okay. So I'm going to do this. Now that looks smooth to me. Yeah, it is smooth. Although it is lifted up off the board a little bit. There we go. So now we have a naked board. Okay. It is 14. This doesn't matter. 13. Control D. And I'm going to call it 6 tall. 6. Select both. Align on this one. Center. Yeah, I figured that would be a problem. Let's extend you a little bit. Okay. That one's clean, so we're good there. Ooh, is it chilly? Okay, we got the proper dimensions for the USB port, proper dimensions for the USB-C port. We have the location and approximate size of the switch. Probably the best thing to do is to simply sandwich it. Print out little standoffs. And have a screw go straight through everything. Yeah, that's probably the best bet. Especially because my power bank that I'm going to build for myself, it's not going to have a flashlight or anything built in it. It's just going to be a power bank. So I only need to solder 2 wires. The input ports on the board. That's it. Battery positive and battery negative. That's it. That's all I have to solder. Well, twice, because I'm going to use 2 boards. I figure one of these batteries can handle 44 watts output. Can it? I guess I should find that out first, shouldn't I? Let's see. C40, 20 amp hour. There it is. Okay. Ooh, that's a lot of money if you want just one. Yeah, I can get these a lot cheaper. I need here we go. Recommended constant current 11 amps. Oh, it can only handle 0.5 C? That's not a grade A cell. A grade A cell would handle at least 1 C. Oh, max current discharge 110 amps. Wow. Max charging current 22 amps. What's this here? Recommended constant current 11 amps. Okay, so it can handle 5 C. They recommend half C. All right, let's bring up a calculator. So that's no, that doesn't make sense. Volts times amps. 3.2 times 11. 3.2. It missed the point for some reason. So 35 watts. So yeah, it can handle 2 of them. Since that would only be 45 watts, I'm only a small amount over that. So it should handle 2 just fine. And these things throttle down pretty quickly as you're charging them anyway. So it'll handle 2. And I should be able to handle 3 no problem. 4 no problem if I use 2S configuration. Let's see, maximum charging current is 22 amps. Sounds like 1 C. Which means the 25 watts that I'm putting into it is fine. 3.2 times 22. Yeah, 70 watts. I wonder, can I plug 2 22 amp chargers into 2 separate circuits plugged into the same battery pack, and will that work? will it put 44 watts into the battery? Or will the two BMCs piss each other off? Meaning, if I connect two of these to the same battery, output no problem. But if I plug 22-watt charging input into two of these, will they both charge the battery at the same time? Or will the fact that one will see the input current from the other one mess it up? Well, there's one way to find out. We're going to try it. We'll see what happens. Okay, so all right. Wire size calculator. Pretty sure I'm going to need at least 20 AWG. But let's just check. None of this is correct. So this is for AC. DC. All right. 3.2 volts. Allowable voltage drop 3% is fine. Current 22 amps. One-way distance is going to be 0.5 feet. Let's leave that alone. I don't know what the fuck that means. Oh, it's recommending 12 gauge? Really? Is this dynamic? Yes. Even 11 amps, it's recommending 18 gauge. With 5% allowance? That gets me 20 gauge. Okay. So the 20 gauge wire will handle 11 amps. And what will I be drawing? 22.5 watts divided by 3.2. I'm going to be drawing 7 amps each. So it'll just barely handle 2. It should. Especially since the second piece of wire is going to actually there's going to be 4 pieces of wire, and 3 of them are going to be less than 2 inches long. Only one of them is going to be the length of the battery, which is probably not even half a foot. But I'd say 5 inches is probably good. Let's go inches. Let's change this to 5. And if I want to draw 14, it's recommending 18. But again, if I change this to 2 inches, it's still saying 20. Okay. So I'll be pushing it, but it'll be copper, it'll be silicone sheathed. I think I'll be fine. There'll be plenty of heat sinking because it'll be pushed right up against the side of the battery. And it can never draw that much power for more than 90 minutes because at that point the battery will be depleted. Well, no, actually it could draw that. Yeah, about 90 minutes. If you account for efficiency losses, maybe 100 minutes, and then the battery will be dead. Okay. Oh, I wish I could tell how thick that was. Really? Is there really no side views? Okay. Guess the trick here is to see how big it is. So from here to here is not telling me. It's not telling me what my selection area is. Is it really not telling me anywhere what my selection area is? Let's make this wider so it's easier to play with. Guess what I need to do is go to this. Are you seriously not going to tell me? Image size. We are 77. Actually, I know how to do this. I'm going to make this 100 pixels tall. Okay. All right. So that's 100 pixels tall. So that's 100%. If I do this, image size, that is 19%. Then if I do this, image size, 77%. Okay. Now I know 77% equals, was it 3.9? 3.16. No, I need this one. 6.2. So 6.2 6.2. I think I divide that by 77. So it's 0.08 per percent times 0.19. No, times 19. So it's 1.5 millimeters thick, approximately. Okay. Wait a minute. Split this again. This. So let's make this 1.6 just to be safe. 1.6. Okay. Line on you here. Line. You. Join you. You. Join you. Okay. There. Now that's about as close as we're gonna get to without having the object in front of us. How much interference do I have? Not much. Yeah, just a switch. Which will be annoying enough. Okay. Which won't matter at all if I create a sled. It would not be very hard to make a sled for this. The easiest thing to do would be to put a bolt straight through the whole thing. Then use multiple nuts to center it. That would not be that hard. How do I want to do this? All right, let's get the basic body in. Since we already know how that's going to work. Think of this. Hey, L3D. I made my own flashlight. So I've decided I want to make... Where's that other battery? What did I do with the other battery? Gotta be here somewhere. I want to make my own... Where the hell did I put that battery? Is it in here? Nope. Not inside the old shell. I don't know what I did with the battery. Not in there. Not in here. What the hell? I don't know where the battery went. Oh, that's creepy. Okay, let's get this moved. I'm probably going to put a strap on this one too. Let's grab all this. Let's copy it to a new workspace. No, I don't have to do that. I can use this one and just reload it. What? I'm annoyed now. What did I do with that battery? Like, I don't know. I do not know where that battery went. I got my little clippers in. This was a freebie. So I got these for a set of nippers. strippers. They work pretty good. Even got a wire stripper built into it there. But the most important thing for me was the cutters and the strippers. It was a freebie, so I grabbed it. But I do like those compact. What I would like to do is to find a pair of wire strippers this big. You know, so a pair of these that just has these on it. You know, something really I don't need this big. You know, for the kind of stuff that I do. I haven't looked really hard yet, though. Okay, let's expand our workplace here. Let's get you guys shoved out here for now. Bring in the parts. Okay. Now I am going to need this and this. You. No, I don't want to do that. Let's do this. Not what I wanted to do. Why would you grab the other part? Like, why would you do that? Okay. I'm going to hide you for now. All right, now let's strip this down. Okay, I don't need any of this. There we go. Get rid of this. And get rid of all this junk. And get rid of all this junk. Okay. Now we can split this again. I don't need you. Okay. Now this channel does need to be bigger. I don't think I need these. If I do this, well, I guess I do need that depth. Yeah, I'll keep those. That's good. Good CAD skills are valuable. Let's stretch this out a little bit. Let's go 20. Should do that. Take you, you, and you, and you. Throwing you into one piece. Something went wrong. What does variable reference dimensions in TCAD mean? You have to tell me what that means. Okay. For some reason, it didn't join these three. I can do that now. There we go. I can live with that. Deepened the channel a little bit. One problem I did run into with my screws that I got, this is not something I had considered, is that I sometimes don't get quite the bite that I was expecting. And the reason for that is this. These screws come to a point. And because these screws come to a point, the last 20% of the screw doesn't do anything. So the solution is I either have to make the tips of my holes conical so that the tips can actually do work to bite into the plastic, or I have to snip those tips off of the screws themselves. And instead of going with 1/2 inch screws, go with 3/4 inch and then snip a 1/4 inch of the tip off. And yes, that's what's that called? It's a variable. Yeah, it's a variable. You're assigning a name to a variable. No, Tinkercad can't do that. No. In Tinkercad, you create um iterations like that by hang on, I think here. Okay, so what I need to do, I need to take this and make it longer. No, that doesn't need to be longer. Just this needs to be longer. And this needs to be taken apart. Oh, I don't want to do that either. Okay, I guess I just need to run it. Hold D, then do this. Um, I haven't decided what CAD software I want to use yet. I'm thinking about trying to learn SolidWorks because SolidWorks is only $50 a year for a non-commercial license. And even though I don't like renting software, um, the entire expected lifespan that I have remaining to me would result in me paying less at $50 a month by quite a lot, versus what it costs to buy SolidWorks. So if I'm lucky, if I'm like stupid lucky, I got 20 years left. So 20 times 50 is only $1,000 for $8,000 software. And I think SolidWorks has a higher probability of being stable, meaning Fusion keeps taking features away. And I don't think SolidWorks is going to do that. I don't think SolidWorks is going to keep fucking with the license and messing with your ability to use it. Well, I think Fusion will. And like even right now, Fusion only allows you to have what, 5 workspaces open. I regularly use 20, 30 workspaces at a time. So it'd be a real pain in the ass with the number of projects I do without paying Fusion for a license. So I gotta really think about that. I just wish they weren't such a dick about it. Guess I only have a couple of batteries. Toggle the. I'll have to look at that. Maybe it's not such a hard problem. Maybe I'm overthinking it. Because I would like to have a more powerful CAD program. How much? I don't need much space. How long is this? I can go another 50 millimeters. How long is this? 25. I want to keep it below 250 so bamboo printers can print this. I think that's enough space because I'll have this amount of, I'll have half of this plus all of this. Meaning I don't think I need this either. I think I can take this, this, and this. I think I can do this. No, this is going to be standing up vertically. It'd be a nightmare to print this horizontally. Okay, think. Now I'm probably going to want to include these. Let's put this over here just for reference. Then we take this and we subtract this and this. Control D. Rotate 180. Then we move it. Okay. Now, question is, how much space do I need? I'm pretty sure this is, I got to double check, but I think that's a 50 millimeter hole. Which means that should be more than enough space. Let's bundle this. Okay. Let's bring the battery back. So there's the battery. And I'll have all this internal space here from here to here, which should be more than enough for this. Yeah, I think that is enough. Don't need this anymore. Okay. Rotate this 45. That puts the A port out here, the switch right here in the middle, and the C port out like that. Yeah. think that'll work. Let's get an approximation going here. So one will go here, and another one will go here, and that is enough space to make sure it doesn't touch this terminal on the battery. I could print a little TPU cap to go over that terminal. And that's enough space to coil up the wire inside of here. This. There we go. Okay, so there will be my two USB-C ports, space for the switch here, and the two A ports here. Okay. Trick is that enough space? Okay, so from here to here, I'm just going to have a tag wire. It's going to connect from that A port to that A port. So I don't need space. I'm probably going to print an eBay. It's going to fit right inside of this and slide in here. So you'll assemble this externally. We'll probably have an XT30 connector here, XT30 connector here. You'll plug the two in, slide the eBay in, and you'll be done. If I do it right, I can even use my little battery wire channel here as a guide to make sure this sits where it's supposed to sit. How long is this? Please acknowledge that I pressed the shift key. We are 229. So I can make it a little bit bigger if I just want to have a safety margin. Yeah, maybe I should. You know, why make it too tight if I don't have to? That's only 232. I mean, 225 would be nice, as there's some printers that are that short, but well, if you got a smaller printer, get a bigger printer. And then I'll do the same thing. I'll have TPU end caps. Screen? Oh, shit. Sorry about that. I didn't know I was still on the regular screen. I'll still have the TPU end caps for shock protection. This is the 20 amp hour cell. These dimensions we already know are correct, so we don't want to mess with that. These will serve double duty. Not only will you have a strap to connect this together with, but it'll also stop this from rolling around when you have stuff plugged into it. Now, the only problem with this arrangement is you're not going to be able to read the display that tells you how much power you have left. Although you could just open up the end cap here. I could even put a hole in the end cap so you can look inside and you'll be able to see how much power is left. The only problem is a lot of this is wasted space. Like, there's nothing going on in here. Is there any way I can make this more compact? Like, how many of these threads can I get rid of before the end cap is not going to attach firmly enough? I mean, this one needs to be this long big because of the pin coming out of the battery. Think. I could also put, I can shape the end of the eBay in such a way that it will insulate this battery end pin from the boards. The eBay also means I can modify this and do different things with this without too much difficulty. Yeah, I think I'm satisfied with that. I would like to make it more compact. But how compact can I make it before I cause myself trouble? Like, for example, I can basically stack these. These could almost touch, and that's not a problem. Not entirely sure how close can I safely get. Now, why would you select the other one? Because you're a dickhead. I would definitely have to put like a printed cap on the end of this battery to make sure it doesn't short anything on the board. But I can go that small, which means I can shift this down smaller. I mean, that should be doable there. And there really isn't much wire. There's only 2 wires going from the battery to this board, and then 2 jumper wires going from this board to this board. In fact, I might be able to make this even easier. It's the backside. It's the backside. So there's the battery connections right there. And I believe those holes are I think these are 6mm holes. I might be able to just. How do I want to do that? Trying to 3D print as much of this as possible because that's free. Doesn't cost me anything. But I think my best solution is to put bolts through it. 4 nylon bolts with 3, 6, 9, 12 nuts, and treat the bolts as a rig to mount everything to. Actually, the base could even be 3D printed eBay, so that everything will line up and slide right in. And then solder on an XT30 connector to the board here. An ST30 is 30 amps, realistically 15. I'm drawing a maximum of 7, up to 14, so XT30 is plenty. Or just 2 bullet connectors. That would mean you could upgrade it, modify it, alter it. Huh. Yeah, let's see what nylon bolts cost. Okay, they're not expensive. Right here, like this, standoffs. Except I can't use that kind of standoff. Why can you go standoff into standoff? Well, the nice thing about standoffs is I would only need 3 bolts, 4 bolts, instead of 12 bolts. I would need these double-sided standoffs would do it. This kind here where you have oh, it's a screw going into one end. Just same thing, it's fine. This would be on the other end. Yeah, okay, so it's 3 pieces. How much space do I need? So 10. Okay. So M5. Wait a minute. I don't understand what I'm looking at here. How can this be an M2 and this be an M4 and the thread all be 6mm? How does that work? Like, seriously, how does that work? Any dimensions? Huh? What am I looking at? length of thread. What is L? Oh. Why is it 5 to 60? 5-30. What the fuck does 5-30 mean? If I get the M5, D measurement is 5 millimeters. That's what I want, because I believe it's a 6 millimeter hole. Double check. Oh, no, it's a 2.6 millimeter hole. So I need the M2. Yeah, M2. The M2.5. Not long enough. I think I can get whatever length I want. So M2.5 thread and 15 millimeter. That's 30. Yeah, it's dirt cheap. Costs next to nothing. 261. That's enough to do. That is 30, which is 10. So that's enough to do. So 2 of these would be enough to do 4 units. 5 units. Yeah. 2 of these would be enough to do 5. Cart. Are they available in Dollar Express? Well, if those were M6, I could probably print them. But M2, yeah, you're not printing that. Not easily. Now that I've added the nylon bolts, it should start showing up in here. That's a little more compact. I don't know if these JSTs can handle that much power. I'll have to check. That would work. Okay. Oh, you can get just threaded rod, huh? I didn't know you could do that. You get a lot of stuff in nylon. I did not know you can get that much in nylon. Cool. All right. I can live with that. Because it's only going to be about $1.50 each unit. It's not too bad. Okay. All right. Let's unbundle. Let's take all of you. And you. You together. Actually, I don't need that. That can go to there. That and that. Why did you unselect? Why did you do that? Shift. Select. Thank you. Don't argue with me. Am I missing something? Oh, I'm missing my internal. Where'd that go? I accidentally deleted it somehow. And you shouldn't be able to see that line there. What the hell? That shouldn't be visible. Why is that visible? Oh, I know what I did. Let's go back. So we need to take all this. You, not counting you. You and you. Bundle group you. Hide you. We're going to take all of you, not you. That should not be joined. I specifically excluded that from joining. Why does it ignore me? You know? Bundle you guys together. Then we're going to bundle you guys together. We're going to line on you. Okay. That should bring them into alignment. For some reason, they were slightly misaligned. No idea why. Oh, that's a new problem. Oh, that's a big problem. This opening is not 50 millimeters. Shit, it's only 42. Oh, that's a big problem. I gotta make the whole thing bigger. I mean, it's not a huge deal, but yeah, the whole thing has to be bigger. Okay, so this needs to be duplicated. You need to come down to here. You need to come down to here. Okay. This whole thing has to be bigger. Or at least the end of it does. Shit. Boy, that's gonna be a pain. Let's just start over here. Okay. Yeah, that's a big problem. This and this line here. Oh, that was a big assumption that I made. That was 50 millimeters. It is not. Up. Okay. Hey, Big Bad Joe. How are you doing? Yeah, see, I was thinking the flashlight wouldn't be a problem because the flashlight gets bigger. I'd forgotten the flashlight gets bigger up here. And this space up here is big enough for this new board, but this space down here is not big enough for the board. Oof. So do I make the whole thing fatter? Or do I just put end caps on it? Because there is enough space. I could just make these end caps a little bigger like this is, where the end caps are oversized a little bit. That might be the best thing to do. Just buff up the end caps a little bit so that they act as shock absorbers. So if you drop it, it doesn't break. Well, the flash, I'm not changing the flashlight. The flashlight, where the dimensions of this are done. Um, um, yeah, this is good. You know, we got over 50 hours of runtime on the double beam. This will run for forever. You don't have to worry about that. But Cassandra wanted one that would also turn this into a power bank. So I do want to make my own power bank. So the first thing I'm going to do is I'm going to make a dedicated power bank. And then once I get the boards in, I'm going to look into retrofitting the flashlight to use the power bank as well. Um, Simply adding the board to the flashlight is not going to be as easy as I thought because the BMS board for the USB ports doesn't have a raw output. So I can't use it as just a strict BMS either, which means my existing circuitry won't work. Meaning I would have to duplicate my circuitry. I would have to have all this existing circuitry and the USB board. That causes problems because there's just enough space in here for all the stuff I have now. So I haven't figured out how to do that yet. Now, what I might be able to do is nope, that won't work either. It's really dangerous to plug. It's really dangerous to plug even a little emitter like this directly into the battery, because if you accidentally leave this on, it's eventually going to undervolt the battery, and that will damage it. Well, the problem is if I fit it to the end cap, then the end cap is no longer a shock absorber. That's the problem. I thought of that too. But the problem is then the end cap is no longer a shock absorber. And this is a pretty chunky unit. I'm really worried about if you print this, unless you printed the whole thing in TPU. But I am concerned about, this hitting the ground and splitting. That's why I'm doing the ends in TPU. Now here, it's chunky, so I'm not too worried about it. It's held in by 4 screws, so I know this isn't going anywhere. And so this will be a good, beefy shock absorber. But this is just threaded on. So if I start building things into the end cap, and then I'd have to make the end cap longer by enough to accommodate the USB board. And now I would also have to run, I'd have to run a wire lengthwise both. So I'd have to run a wire from this end of the battery to this end, and this end to this end, because I'd have to have the 2 terminals over here to power all this stuff, and the terminals down here to power this piece. I mean, that could work. I gotta think about it. I mean, the easiest thing to do would be to extend the battery cap this far, like that much, and then have a hole in the end here that the USB board would fit into with the appropriate openings for the USB sockets. And then you would have a 3D printed, couple layer PETG. If you did it in clear, you'd even be able to read the screen. You would then put that on top and screw it in place. I could have the threads built in. It wouldn't protect the USB board that much, but the USB board doesn't need that much protection. It's a pretty durable thing. Yeah. That's not a bad idea. And it wouldn't be that hard to add a second channel. It would make the whole thing more expensive because you'd need more wire, and then you would have. I wouldn't be replacing the components in here with the board. It'd be a duplication. Oh. But now there'd have to be enough space in the end cap for excess wiring, because you'd need enough excess wire to be able to unscrew this and take it off. And I can't just coil it up in here because the pin for the battery goes this far. So I can't use the space in here. It's already being used. No, it won't, because it's going to have the exact same problem. That's not okay. The restarting thing is not a problem. It's a feature. It's supposed to do that, because otherwise the BMS would drain down your battery to 0. That's the whole point. It has to be able to disconnect itself. Otherwise, it becomes the drain that drains your battery to 0. So that's why it's designed. Okay, when you plug it into charge, then it activates the board. That has to be there. I didn't realize that the BMS is going to consume power doing its monitoring. So it itself is going to drain your battery to 0. So there has to be a way of disconnecting the BMS. That's why to put this in storage, we're going to have to disconnect the battery. Now, the one thing I was hoping is that I don't know if this will actually work or not. I think it will, but I've seen situations where it doesn't. So here's the little board for the USB. Now the problem is, if this had a raw 3.2 volt output, if we would output the 1S power through the BMS, then I could replace all the electronics I have in here now. I would no longer need the PD trigger, and I would no longer need the BMS, because this would do that. The problem is, the only outputs from this board are the USB ports, which means I would have to essentially tap into plus and minus on the USB-A to run to my circuitry for the flashlights. And then I would also need a step-down converter to step down the power from 5 volts to 3 volts. And that's going to not only add more components that have to be soldered now, but now you have the problem of you're doing double conversions. You're going from 3 volts to 5 volts, back to 3 volts again. And all that double conversion is going to trash your efficiency. So now instead of getting 50, 60 hours, I don't have the means to do that. So the way this works, when you unscrew this, there's your battery connection. So this battery is a cylinder, and one end is positive and the other end is negative. So there's no easy way for me to turn this into a switch. There's just no practical way for me to do that. Now the solution we came up with, which for the flashlight will work, is I will when you put this in storage, you're gonna disconnect this, and then you're gonna reconnect it. When you reconnect it, the battery will not be draining because the BMS will be in an off state. Now, what we have to do is we have to jump the BMS, bootstrap the BMS. We tested this last week and it will work. What I'm going to do is I'm going to put a small momentary toggle switch right in here, probably in line with the USB port here. Okay, so a small momentary toggle inside the threads. So this will still thread on, and that switch will be installed from the inside. And what will happen is I'll take the 3.2 volts that go to the BMS, and I'll run it to the terminals on the USB-C port, because it has a screw terminal on the back. And then one of those wires will go through the momentary switch. So you basically, you're going to raw dog it. When you have this in the off state, you'll know it's in the off state because that light will be off. So you'll unscrew this, unplug your battery, give it a count, 5 count, plug it back in. That should remain off. Screw it together, you're good. Your flashlight is now storage ready. And when you're ready to turn the flashlight on, you'll unscrew this just enough to take your finger and push that momentary switch, which will momentarily take the raw 3.2 volts from the battery and backfeed it through the USB port to the BMS, which will bootstrap the BMS on, and then you're good to go. You close it up, and this will be lit, and your flashlight will work fine. We've already tested that. That works. So that's how we're going to handle the storage. That also means, nicely, no tools, because I really want to avoid tools. Because I want this to be something that you don't have to fiddle with anything. And that's even better than reconnecting this, because now this will be all connected, all ready to go, and all you'll have to do is unscrew this, tap, see the light, screw it down, and you're good to go. Your flashlight's ready. Um, I haven't tested yet to see how fast that drains the battery. It's probably months. So if you know you're going to be using this reasonably several times a year, you could probably just leave that alone. But if you're going to put this in a go bag or an EDC kit or something like that, or a preparedness bag, then you're going to want to disable the electronics, and that's how we're going to do that. So that's no problem. That's easy. I suspect this board will have something similar, where the output will be disabled. Now the thing is, this has a switch, so you have this little switch right here. Now this does not always work, but some of these devices, they'll put themselves in a sleep mode, and then you press and hold that button, and that turns it on. The problem is, I know sometimes that doesn't work. I know sometimes these battery boxes that I use, they'll go to sleep and you can't wake them up. They won't work no matter what you plug in, no matter what buttons you push. The only way to wake them up is to feed them power. And that's the same thing that we're doing here when we jump this. So that same thing's going to have to happen. Likely the jump switch that I put in to jump this will also work for that. But I don't know how to do it. This doesn't have screw terminals. And only this USB-C port is bidirectional. This is not. See, this one has easy to solder terminals. So there's your ground, and either this one or this one is your positive. And no, and that's the other part. It won't restart when you screw it back in. When you reconnect the electronics, it does not restart. You have to jump it. You have to plug power in. Now the good news is we can use the 3 volts coming out of the battery. I was afraid it was going to require 5 volts, but apparently the 3 volts coming out of the battery is enough to jump it, which means we don't need any external components, which is good. I do not know what this thing requires to function. This very likely has a similar state in which it disables itself when it's not working. Now this one might be as simple as an interrupter. So put a switch in line with the power, and then I might be able to just turn it on and off with a physical switch. I don't know. But this has to have some way of turning itself off, because otherwise, okay, a BMS has overvoltage and undervoltage protection. That's the whole point of a BMS. To control the output current, to control the input current, to handle charging the battery, and to prevent overvoltage and undervoltage state in the battery. Overvoltage would be charging, so don't charge past the full correct voltage of the battery. Undervoltage in this case would be don't go below 2 volts. That's the minimum state for the battery is 2 volts. Now here's the problem. If the BMS is monitoring the battery to see if it's going down below 2 volts, that means the BMS is on. That means the BMS is using power. So the ultimate undervolt protection must include the ability to cut the BMS off entirely and everything turns off. Otherwise, the battery would continue to drain. So that BMS has to have a way of turning itself off. And if it can turn itself off, well, it can't turn itself back on because it's off. It's like Data trying to turn himself back on. Someone external to Data has to come up and hit the switch in his back here to turn him back on again. He can't turn himself on because he's off. So the same thing would happen with the BMS. That's why we have to jump the BMS, because if it could turn itself back on, that means it's never off, which means it's continuing to drain the battery. So the off has to be latching, basically. So this board will probably have some similar feature. The question is, how do we jump it? Does it require me to plug in a USB port? I guess I wonder, does this output anything? I doubt it. Yeah, I get nothing. Okay. I plug in my little test meter. See if this USB port puts out anything. However, that might be enough to jump the other BMS. So when I press the button, I'm back feeding power into the USB port. No, but see, I'm back feeding it directly to the BMS though. This board has a chip, so there's circuitry there. The question is, if I plug 3 volts into the back side of this, will I get 3 volts on this end? If I do, we could do a USB-C cable from here to the BMS in the cap. And that might be enough to jump the BMS to get it to turn on. You know, you'd hit that momentary button and that would also jump this. I don't know. I won't know until I have it. See, the problem is I don't know if I have the skill set necessary to solder. I mean, I imagine if I connected the 3 volts to the positive and negative of this USB-C port, that would probably do the trick. The problem is I lack the soldering skills to solder that. I can solder these, but I can't solder these. I don't have the tools. And now we would need 4 sets of wires. Or we would need a second switch on this end to jump it. You know, we would need another little switch like this to jump the 3 volts that we already have running to this. So basically I'd have to connect this positive to this positive, this negative to this negative via a momentary switch, so that I could boop and bootstrap the BMS. Don't know. Nothing on the backside really. I don't know. I don't know what connections on the USB port are power. To avoid that problem, it'd be a bodge. It'd be a pretty ugly bodge, but I could do this. USB-C male tail. I could get these. These are like this right here is a USB-C with just power. And I could just leave space inside the flashlight to store this. And have this connected directly to the battery under the cap, have enough space in the cap to store this USB cable in. Then what you would do, this again, this is assuming 3 volts is enough. You would unscrew this and you'd have a USB-C cable on a pigtail sitting here. And what you would do is you'd plug that into the USB-C on the BMS and that would boot it up. That could work if this BMS is smart enough to or dumb enough to accept the 3 volt tap as a okay, time to wake up. I'm not sure. I don't know if that'll work. Do not know if that will work. The only way to know that would be to try it be to buy a couple of these. I should be able to get them raw cheaper. Like without the sheathing. Just a bare metal. Huh? You know, something like this. Like this. Yeah, see, bare board. See, V&G. That would be about as small as you're going to get. And cheap. Like this. Here we go. There we go. That's what I wanted. This one micro. Type C mail. There it is. $5. Wow, they're expensive. Cheaper to go the other way. That's Type C female. It's male. Yeah, it'd be cheaper to go the other way. I'm surprised those are so expensive. Huh. And shipping. Ugh. Yeah, it's much cheaper to go like this. The advantage of this is it would take less space in the tail cap. Yeah, I just solder my own connection then. That's way too expensive. Probably this would be the cheapest bet right here. Male. What is the difference here? That's all I need right there. Ouch! Oh, what the hell? Look at that! 10 of them is $5.74. So you how much is it should be $11.50 for 20, but it's $22.29. So it's cheaper to buy 2 of the 10 packs. What the hell? I tell you, sometimes their pricing just doesn't make any sense. Yeah, this would be the one because it's got the nice big connections. Yeah, V bus and ground. So positive and negative. So we would get this with a little bit of wire connected directly to the battery. And you would just boop and bootstrap your flashlight. That could work. Add this to the cart. That would be the nicest option because we're not running any power. So you just get the thinnest, 24 gauge wire, just a super thin wire. And just have enough space in the end here to store it. Okay. Think, Chris, think. How do you want to do this? All right. If I got to fatten up one end. Oh, I got to think about. Let's see how this would look. See? Okay, would definitely fit. Okay. So it would definitely fit. How hard this would be to do is going to depend on how much of a pain in the butt this is to turn on. This does solve the problem of being able to see the percentage display, but I was also hoping to have this all be internal for maximum protection. But for fitting this to the flashlight, this would be the easiest way to do it. Yeah. Okay. Ah, okay. So I can do that. Okay. Why won't this shift? Oh, it is. It's just doing it very slowly. Yeah. It won't let me do it for some reason. No idea why it won't let me do it. Every now and then it just won't let you do that. There it goes. Okay. Okay, so now I want to take this and this, join them. Should expose the internal parts. Yes. Take these two, join them. Like that. Okay, that gets me the end cap I need. Gonna need to do this. Probably there. Okay. Now we Control D this. Take one of these and hide them. Take the other one, dismantle it. Delete this. Delete this. Dismantle this again. Make this 1.6. Okay. Control D. 80. Okay. That covers up the holes. Take you. Come on. Oh, Christ's sake. Good. God almighty, you gotta be so pain in the butt. Where the hell's the other axis? There it is. Come on. You always gotta be such a pain. Really? Okay. You want to go 105%. That's too big. So 101%. 101%. Maybe more. 102.5%. Not what I asked you to do. Bastard. Shift. Hate when it does not recognize what I'm doing. That should do it. Now we want to raise this 1 millimeter clearance. Then extend it like this. Turn it into a hole. Bring back the other part. Just like that. Okay. Take this part and this part. Cut it down. Take this part. Cut it down. Take this part. Raise it 1 millimeter. Okay. So there, we have the space to insert the board. Is that enough? I think I need a little more meat here. Which means I think I need to lift this up a little more. Come on. Fucking let me move it. Hell is your problem? Why won't it let me do this? Oh, for Christ's sake, go away. Let me do this. It won't let me do it. Why? Why the hell can't I fucking click this? I think I'm pushing the computer too hard. Let me close some stuff. Close Photoshop. What does turned off in view list mean? I don't even know what that means. I click here. There we go. I was trying to put the work plane there and it just wouldn't let me do it. I don't know why. It's just being a dick. I think I'm just pushing this computer too hard. I can't do that because I cut too much. Okay. Oh, come on. That's why. What's the eye symbol mean? You know? Sometimes it just doesn't let me grab this tool. Just, I don't know why. Okay. That's a little deeper than I need. Do I have to go that amount? I guess I do, don't I? I know what I can do. I can shorten it. I symbol. I don't see anything that represents an eye. Where's an eye? I was just trying to get it to let me move the plane, the work plane, but it wouldn't invoke this so that I can do that. I don't know what an eye is. I don't see any symbol that looks like an eyeball or a letter I. Okay. Now we take this, split it. Now we take this. And we put the work plane here. Select this. This. 104%. Let's do a 5%. Okay. Then we take this. Of course, it's off the screen. No, that doesn't apply to the work plane tool. It was just glitching for some reason. Let's see. 5%. Actually, no. Those have to be. No, I do want it 105% like that. Okay. So now we turn that into a hole. Turn this into a hole. Take this and this and this. Okay. All right, that gets us our base hole. But the base hole's not going to work. I do need to do something else. U and U. Control D. Then U. Then U. Because I now need to add a bevel. Okay. Need to put a bevel about, I want to say there. We take this, put here. Okay. We're going to change this to 4 sides. Hide you temporarily. Okay. bring the height down to here. Top radius to like that. Actually, keep the top radius minimalized first. .51 by, where the hell was the goddamn, so fucking jumpy. This computer is so, why does it have to be off the screen? Why? Why does this need to be that tall? Why can't you put that box, this box, all the way down here where I need it? It's like, why is it up there? 651 1365. Oh my god. Seriously? It's down here now. Now this one's all the way down here, off the edge of the screen. It's little things like that that just make you just. It's like, come on, work with me. Okay, so we need you there and you there. Okay. Now we take this and we adjust our top radius. Okay. Now we do the same thing over here. Okay. Put a work plane here. That is not what I wanted to grab. This one. Okay. Really? They're both off the screen. I mean, who needs to see them, right? We don't need to see those numbers. There we go. 332939. Needs to see it. Nah, we don't need to see it. Okay, so there. Take this. Adjust our top radius. Something like that. Okay. Now what I definitely need to do, I definitely need this to be wider than the USB port. Boy. No, we're trying to add the USB two-way charging. I'm trying to design for the new circuit board I found. This one. I found this. So this is lithium iron phosphate compatible. It's 1S compatible. It has a USB-C bidirectional port and a USB-A port, and this allows bidirectional 22.5 watt charging. So not only will this allow you to charge USB devices, but it'll allow you to fast charge them. The only problem is this would be in addition to all the circuitry already in the flashlight, because this is not this does not give me raw 3.2 volt output from the BMS portion of the circuitry so that I could run the flashlight. So I would have to run basically a dual BMS system to use this. Although I could get rid of the QC plug on the other half of this. We would not need this anymore. Maybe. Thinking about it. It all depends on if this turns off and whether this needs to be jumped, turn back on, how that works. So I'm experimenting with adding this to the cap, since there really isn't enough room in the other end. All right, that should be enough width. Gotta do the same thing here. This. This one should actually be a lot easier to do. Come on. That. Okay. Now, we don't need as much up-down deviation. Okay. So I think I can take this and put it here, lift it 1 millimeter, which of course I can't do because it's not showing me the goddamn number. Oh, come on. Why does the UI have to be such a pain in the ass? Why can't they figure out the UI? 1 millimeter up. We take this, and we lop off this excess. Okay. Then we need to do the same thing to the other side. Let's hide this for now. Let's do this one. Same thing, come up 1 millimeter. Okay. Hide you. Take you. Go down 1 millimeter. Why do I have to do it again? Why didn't you do it the first time? Test. That. Same thing here. 1 millimeter. Nice. It cooperated. That's a miracle. Okay. Oh. Back. Okay. Should be that simple. This and this and this. But 1 millimeter might not be enough. Yeah, that should be enough. So that should be enough to allow pretty much any USB cord to go in there and any USB-C cord to go in there without interfering. We might need to fatten them up a little bit. Wait a minute, from here to here? It's only 1 millimeter? Huh. I would not have guessed that. I think I need more space. I do not think that's enough. See you later, L3D. You're Luke. Yeah, Luke. I haven't seen you in a while. Okay. Let's go 7.31. That's too much. 6.31. No. Let's do 7.31. And then just drop it by 1 millimeter. -1. Let's go 9. 10. 9.5. Wait a minute, what was that original number? Oh, yeah. 10.5. And where'd the 1 go? Then drop it by -1. Okay. Let's see what that does. Yeah, that looks better. That looks much better. I'll beef it up more if I have to. Okay, now we have 1 more to do. Hide you. Don't need you anymore. Don't need you anymore. Need is a cone here. Let's make a base radius of 4, 2, 3. Ah. Yeah, we're pretty centered. Sure, I can squish this down quite a bit. Okay. Okay. Centered. There we go. Right, that works. That gives me access to that switch. Except I need to do this. You. Okay. We take all three of these, put them together. Here we go. Now we have access to the USB ports. Okay. I think we have enough meat to protect it so it won't destroy it. Okay. All right. That's where the holes will have to go. Use some nylon screws to screw that in. Or just, there's enough room on the board. No, it needs M2.5. Yeah, the number 8 is going to be way too big. Battery connections are to the left. So, wait a minute. What's that? Opposite USB-C port. So the battery connections are over here. Means I'm going to want the hole to be over here. Let's do a 6mm hole. I think will be enough. 6 by 6. And of course I ignored it. There it goes. Just trying to be a dick again. There we go. You and you. I'm showing the right screen, aren't I? Yes, I am. This will require almost no modifications to the flashlight, which is good. Just have to solder a second wire to the... Oh, we don't even have to solder, just to this. That would be the circuit board. Wires would come in right here. Where are those wires? They would come in about here, about here. I'm tired of having two windows pop up. So they almost line up with these holes. That means right about there. Right about there. The inside or outside? Outside. If we do this, ooh, what does that do to the ring? It cuts through it. I don't care how badly. I'm sure it does it all the way. See, gotta make sure it cuts through all the way. Otherwise, it'll make you thin stuff that'll be real messy. You do not want. Okay. Boy, that's a lot of bridging. Oh, that's messy. I forgot about that. Oh boy, I forgot about that. The only way to fix that is to make it two parts. It would make it stiffer. How much meat do I have in there? I've got a decent amount of meat. So I could cut this in half. Yeah. Then just use two screws to screw it together. Yeah, I could do that. They're not supposed to do that. Well, it might be because I'm really low. So if you got me turned up so you can hear me, then the ads might be really loud. That might be my fault. What's the mics doing? Yeah, they're a little on the low side. Not bad, though. It's in the green, at least. I can boost my end a bit. Boost it. Let's try to get to you. How's that? Is that too much? Oh, sorry for the earphone users. That was probably loud. But if I make myself louder so that you have to turn me down a little bit, that'll make the ads not so loud. Sorry for the sneeze, headphone users. Yeah, this is going to have to be 2 pieces. Okay. Let's see here. This is the wrong way to do this because it's going to increase the workflow issues, but I don't care. Okay. And of course I didn't get it all. I mean, that never happens to Tinkercad. You never get it all. Let's get rid of you for now. Control D. Okay. Let's do this. Solid again. I want to Control DU. Okay. You and you. Fine. Make a different color. Take you back, join you with this half. There. Now we have 2 pieces. Okay. Now, need to put a hole in here. Actually, we need our screw head, which I do have. Port. Choose. Is it at? No. No. I moved them. Number 8, modded truss screw. Port. Let's clean up the workspace a little bit. Where did the screw go? There it is. All right, just in case I want to mess with this. What the fuck is it collecting? Are you grabbing this? There we go. Copy. Delete. New. Paste. All right, so if I want to mess with you again, I can come back to you. Go back to you. That'll really reduce my memory usage in here. Oh, I don't need you either. I could take all you into the workspace a little better. Okay. All right. Head. I need a 12 by 12 hole for the head. You. One. You. All the way through. Yes, it is. Okay. D, Control D. Join you together. Turn you into a hole. Control D, duplicate you. All right. One pair of you go into this one. One pair of you will go into this one. Oh, nope. I got to put my hole in first. Need two 12mm holes. Okay. I need to split you. Control D. One of you has to go here. And one of you has to go with this one. You deselected for some reason. You, here, and here. Okay. Gotta shorten you so I can see the screws. Okay. Screw and screw. Hole. Join. Then join. Which didn't work. Then join. Okay. So now we have the threaded holes. Okay. Oh, I don't want to delete. Hide. Okay. Actually, this just needs to be holes. I screwed that up. Okay. We do need you and you. We're joining you together. Hide you. You guys do not need to be screws. So I just need to do one. How big? So 5mm hole will do it. Oop, no. Yeah, I can do that. Okay. Hide you. Hide you. I want to separate you. Right. Control D. Five by five. You and you. Are you going to let me select or not? Center. Control D. Come on. You grabbed the damn little thing. Five by five. Line. Okay. Grab you. You together. You together. Let's do this. Line, you, bottom. Okay. Lift up. 5. That's plenty. Actually, 4 is probably enough. All right. There. Good. Oh, I don't want that. That's horrible. I never even centered this, did I? Did I ever even center these? Nope, not even close. Okay. Hide that. Let's do this. Oh, those are available. Okay. Okay, we want to unselect you. We want to center on you. There. Okay. And we also need to shift it all. Okay. All of you. Unselect you. Unselect you. Okay. You and you. I don't think that worked. There it goes. Oh, that is no meat whatsoever. Oh, that's not enough. This is in the wrong spot. The cut line is in a totally wrong spot. Okay. Let's try this again. What am I doing? You, bundle group you. Let's just do you this way. Why do I gotta be so hard on it? This does not need to be this complex. Did I somehow join this with it? No. What the hell's your problem? All this, then take that away. What the fuck is the problem? There. Every now and then you just need to hiss at something. This doesn't need to be this deep. Okay. Let's move this up 5 millimeters. 5. And then we take this and this, rejoin it. And we take this. We add 5 millimeters. That doesn't want to work, so let's just do this. 5. Easy enough to do. Easy peasy, yummy squeezy. I'll call you back when I'm done my stream. Alrighty, now this is all joined. Unjoin it. Just need these two to join with this one. We need these to be transparent so we can see the holes. Okay, so we take, those are joined, right? Yes. This and this align on this on the bottom. Then give ourselves 5 millimeters of clearance. 5. Is that enough? No, it's not. Okay, we need to be inside. Let's go. Yeah, 2 millimeters is enough. Now we take all this and join it. There. Now there's enough meat in here. Those two to join. And then this is enough to recess the screws so it doesn't touch the USB board. Okay. Pre-threaded holes to accept the screws are there. I do think I'm going to knock off a little bit on this. Okay. Move this up. I think we're going to, yeah, I think, let's go -3. That'll be enough to be a shock absorber, I think. I really don't want to do that. Let's do, oh, yuck. I sure as hell didn't want to do that. Dumb, stupid thing. Why won't you turn red? Hey, Maker Viking. I think this will be enough. Yeah. Just enough so that it doesn't tear apart the wires. Ow! Wow. Yeah, that's different places for the wires to go while these are still tall enough to support the battery. All right. I think that'll work. I'll probably want to design a plug to fit in here. Shouldn't be that hard to do. Just take the insert that I used and just print a short one to fit in here. I might even be able to fit the two of them in here. So instead of having a separate power bank, just have one unit that's power bank and flashlight all in one. Okay. It's going pretty good, Maker Viking. I found a really affordable 1S lithium iron phosphate bidirectional PD board. So this is 22.5 watt bidirectional USB-C PD and also USB-A. It's only $4.50. So I'm designing this into the tail cap. Good to heat. Oh, good to hear, probably. Nice. So I'm redesigning the end cap. The nice thing is I won't have to change the rest of the flashlight. Oh yeah, I do have to add a channel. I forgot about that. Okay. I need to just get rid of this because that's not going to print very nicely. Now I'll leave it. Nope, going away. It's going away. Okay. I just don't like the way that will print. So it'll print like shit. Okay, that's better. Okay. 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 Oh, wait a minute. Oh boy. I do need a riser. Let's see. I guess right here, 1mm disc on each of these locations. This. Do a 6x6. 6x6. Do a 5x5. 5x5. Too big still. Okay. I'll make it 1mm tall. One. Maybe we will make it 5x5. 5x5. It's good enough. Wait a minute. We are going to need to put a 2mm hole in it. By 2. Come on. What am I doing? Come on. Just let me grab the freaking cylinder and move it. Wanker. You and you. Really? You're not going to let me grab this? Okay. All right. I guess I go all the way down, don't I? Control this. You. Okay. Right, you. And you. We're gonna bundle group you. Yeah, I do too. The knurling is nice. This makes it easier to grip. One of you is going to go over here. One of you is going to go over here. White. The hell? Can't I see it? Why can't I see the cylinder? It was like it was hiding it. I don't know why. Why is it invisible? There it goes. I don't know why it was making it so hard to see. Huh. See how it's making it disappear? Well, I know one way I can fix it. Let's do this. That. Oh, you gotta be a pest. Oh, it's when I bundle group it for some reason, it makes the goddamn transparent cylinder. There it goes. It makes it partially disappear. I don't know why that's so hard to see. That should not be that hard. See how much better it is now? I don't know why it's making it that hard to see it. I need to see this shadow so that I can center the shadow in here like this. But for some strange reason, when I bundle group them, I lose the ability to see the circle. I wonder why that is. That is what I wanted. It's hidden. There it is. See, again, it's not centered. I need to be able to see it. Okay. Go. Okay. That should be correct. Should be able to hide that. Hide this. I should be able to take this and join it. Okay. These are recessed. I need to open this. There's no reason for this to be like that. Boy, is that going to be a pain. You know something? This is the lazy way, but I'm going to take the lazy way. Yeah, I'm going to take the lazy way. Definitely going to take the lazy way. Okay. Control D. I'm just too damn lazy to go all the way back. I just don't want to. Doing something. Oh, I think you did it. Oh, this shouldn't be here. Okay. There we go. This way these wires don't get pinched. Okay, so this will screw on. This whole thing will screw onto the flashlight. Second set of wires will come through here. These two pieces will screw together. This way I could print these two pieces separately without having to worry about support. Those two will screw together with the 1/2-inch screws. Then you'll use M2s, the nylon bolts, to bolt the board into here. Now that I think about it, I probably should. I probably don't need these. I'm betting these nylon bolts all the way through will be enough to secure them. First, let's clean this up. They are separate. Right. Control D. Thought that might be a problem. How do I fix that? Okay, let's do this. Hide you guys. Hide you. Join you. Okay. Bring everything back. Let's hide you. Let's hide you. Okay. These should all be the same size. 66. Okay. Now we take this, join them. Okay. Bring it down until it pops through. Why won't it move anymore? Minus 13. Wait a minute, which way's up? All right. Minus 13.5. On 3.3. 13.2. That goes away. Minus 12. How far in do they go? Is it enough? Yeah, that's plenty. Okay. Right. There. And I should. Let's see, will it fit? Can I fit two? I'd love to fit two. Roll D. Raise you up by 10. Yes. In theory, I can fit two of them in there. It might pop out, though. I might have to make this a little bigger. I don't know how tall this thing is here. But I might be able to put my double header in this. We'll see. We'll do the one first. We'll see how that goes. Okay. Okay. I think it'll work. Okay. We're going to call this USB at 1. Really, caps lock has to be on. USB cap 1. That's going to be this piece. don't think they're in country yet. Should be today or tomorrow, though. Go away. They are import customs clearance started. Okay, so they're in country, but they haven't gotten out of customs yet. So they probably won't get out of customs until Friday or Saturday. So next Monday or Tuesday they should be here. Of course, I won't get an ETA until the USPS has it. Export STL. Okay. Okay. In theory, this will allow this to that means I can that does mean I should be able to get rid of this. I don't think I need that anymore. I might be able to replace that with a switch to bootstrap this to turn it on. So I might be able to replace that PD trigger hole with the option to disable, not disable, but to boot up the battery. That might work. Now, the only thing I don't know is I don't know how well this is going to stand up on its tail cap if we do this. We'll have to see how well that works. Okay, let's see how these slice. First, we clean them up in Prusa Slicer. Right. One shell. Looks like it didn't find any errors. Still going to fix it. 33,806 to 33,386. So it looks like it did find a couple little things. All the holes are there. Yes, all those holes are there. Okay. Export. It's cap 1. Cap 2. No errors detected. Run it by the algorithm anyway. Did a little change. Make sure everything looks good. You let me rotate. 4 board holes are there. The 2 mounting holes are there. And the pass-throughs there. I don't think I need these holes here. But we're going to add them anyway. It doesn't cost anything to add them. There's a couple of annoying bridging areas here, but that should be okay. Sometimes when you have your program will okay, how do I describe this? Basically, your model has defects. It has flaws in it. And those flaws can sometimes cause slicers to do really fucked up things when it tries to slice your model. Most slicers, including Prusa Slicer, Orca Slicer, and Simplified 3D, will all do some corrections if they notice flaws, but sometimes when they correct flaws, they make the model worse. Like when a model is multiple shells and it shouldn't be, if it's not manifold, if there's missing triangles, if there's unclosed polygons, if there's micro gaps where there shouldn't be, things like that. Um, that can sometimes really cause a problem when people try to slice it, especially if it tries to treat a model as multiple pieces when it's not, because you get overlap. And Tinkercad sometimes inserts these flaws into models accidentally, especially when they get really complex. Usually it does a pretty good job. Like you saw today, both models were single shells, and there was nothing to fix, but I did it anyway. Sometimes, however, I'll export a model from Tinkercad and be like, what did you do to that model? And usually Prusa Slicer's built-in correction or the Windows repair algorithm is usually enough to fix it. And so I run all my models through that first, just to reduce the likelihood of people who download my models having problems with them. Because I might not see the problems because Simplify 3D fixes it. But if you're using a different slicer, it might not fix that problem. So the cleaner I can make the models, the better. Okay. All right. You definitely want to print this one first. I'm going to print you over here, you over here. So we will do a sequential print. Let's get my base settings correct. 444. No, we're definitely doing 0.3. 3, 3. Let's go 2. We do not need 30%, but I think 20% might be enough. We are 240. 50 is enough. Damn it. We need to really slow it down, though. 14 and 70. I think we're going to do it as 8 and 30. Now, tools, variable, different for each model. Okay. Why do you insist? No, you're doing it right. That's the first one. That's the second one. Yes, okay. Okay. Pair. Sequential. 999. See what that looks like. 6 hours. That's a long time. Okay. I think we're good. That will fail. I'm going to get rid of that. No. We are 43.42. We're going to do a, let's take 0.6 off. 7, 42.72? 42.7. 42.7. That should get rid of those two thin layers that I don't really want it printing. Yep, got rid of them. Good. Okay. I wish it was complete and not little holes, but whatever. I do want these a little bit stiffer so that we don't bend the board. Hopefully there's enough play in this. I think I've built enough play into it. Okay. I think we're good. USB cap. This will be on flashlight. USB cap. The nice thing is I don't have to modify the parts of the flashlight. All I have to do is connect one of this to the end of the battery and this to the other end of the battery. So 2 ring connectors on the battery. They're basically independent of each other. So work completely independently of each other. Okay. Which is good because that simplifies things. I really like simple. All right. I'm going to print this. Got the filament right below me. And we will see how it goes. I'm not even going to bother designing a cap to put inside this until, we make sure it works. Then what I'll probably do is have a little ridge in here, and I'll have a little insert cap. There'll be a couple layers of clear PETG that will just force in there until it clicks into place. Ideally, all the way in so that it touches the top of the little screen. This thing here. I can't design it now because I don't actually know how tall this is. But if I have that cap go all the way in so it touches the top of this, then you'll be able to read the screen through the clear PETG. That's it. Okay. I think that's it. Okay. But this will give you your this will allow you to use your flashlight as a power bank, Cassandra. And you just have to buy 1 extra board. I'm going to order a few of those boards if they work well. Let's see, I do have to make 1 change to the flashlight. I do have to make a change to this. So let's hide this. Let's hide this. hide this. That gets us into the guts. Because for this to work, 6 by 6. Come on. Oh, he's got to mess with me. Okay. This is going to be 200. I think that's wrong. I think it's 4 by 4. What the hell is that? Did I scale it somehow? Or 4? Did something to it. Okay. Yeah, I do need a bit more space there. How do I center this? I know how I can do it. D. Select U. Okay. Hide. Okay. Hey, what did I separate? I separated something. I mean, I hit split. That, whatever that is right there. That's the hole for the screw. Okay. For that. What the hell did I just separate? Something separated? Oh, that. Yeah, I need to fix that too. Yep. Oh, come on. I want to go through all this. Fuck, did I separate? Oh, that. You need to fix that too. Come on. I just need this piece. Jesus Christ, how far back? Let's go. I don't know how far back I have to go to get to that. Oh, still not there. There it is. Finally. Jeez. Jeez Louise. I don't care. I just want to chop off a piece of you. Just gotta chunk off a piece of you. So I have room for these two channels here. In fact, I might as well put them in now. There. Now I've got the channel for 2 wires. Since I'm going to have to wire up both directions to do what we want to do. Okay. All right. This is where it gets messy. These should all be separate pieces. Yes. Why? Okay. Okay. We have that. Those did not connect. Why? They must have been just off the edge somehow. Is it not selected somehow? No, that's selected. That is so not what I wanted to do. I want to merge, baby, merge. Right, it's all orange. There it is. Okay, that's all done. now for this mess. This is going to be messy. Let's do this. There. Control D. Get rid of this altogether. And one thing I don't like is how thin this is right here. I don't think there's a whole lot I could do about it. I need to take all this, make sure I do not have this selected. Why is this here? Oh, it's processing. Get this ready. Something like this. To go. Come on. You've already done this before, so it shouldn't be that hard. Probably what I should do is extend the tail cap. But no, I can't do that because that's what holds the battery in. That's why I didn't do. Oh, man. Well, I hope this doesn't fail. Suck if it did. I like the fact that that's not selected. Let's do this. Oh, I think I broke something. Oh no, I got micro lesions, but it's okay. Alrighty. This I need to fix. So this, why can't I change the size in the middle there? Okay. I think I need that size hole. I can now delete this. Take this, center it, this, that, and join. Yeah, since this will be able to charge the battery, I might be able to get rid of this QC port and put the momentary switch in here to bootstrap it, but I have to figure out how to bootstrap the new board. I don't know how to do that. I enlarged the channels, which I needed to do. That should be sufficient. How's it go? Body. Export. Hey. Yeah, this will work. Oh, I made the bonus amount for this month too. Should be by enough of a margin that even if I get a return, I should still be okay. Yeah, $4,000. So I got the $115 bonus. I wish I could have got that last month, but hey, better than nothing. Next month it's only $85, but it's $1,000 lower. But hitting that in January is going to be really hard. January and February are pretty bad, but still, at least it's a lower threshold. But yeah, I'm super excited. I at least got one. Come on, export the model already. Did it. Yep. Both go into here. You bastard. It popped up right as I was about to do it. Of course, that messes up my listings. Okay, body. Yow. Face on face. Auto repaired 20 errors, one shell. Definitely want to fix my Windows algorithm. I don't care. Yeah, that looks good. Export. Body. Put the body in there. Place, yes. Okay. That's it. As soon as I get the board in, we'll test fit it. I'm going to print those parts out now, and I'll be able to screw them together and make sure they fit the flashlight okay. And I'll print out a new body. Although I have more of that plastic. I like this orange. I like this orange a lot. I think I'm going to shorten this a little bit. It's a little too long. Although with a glove, that'll be a good fit. I also got rid of the crossbar for now. Made a bigger hole to slide the wires in for this. Hopefully that's big enough. Use thin wire for this because it's drawing less than half a watt. I might be able to get rid of this and replace it with a momentary switch to bootstrap the BMS. See how that works. Can't think of anything else. I got the 2 channels. The channels are deeper now. We're working on a new cap to add the USB. This is all basically done. Get your 2 lights on top, single side light on the back. Yeah, I think we're good. Oh, I wanted to move that switch a little bit too. I'll work on that later. I want to move this switch up a little bit. I've got room, so further up it is, the more recessed that is. So I do want to do that too. That's it. All right. I want to call it quits for today. Make some lunch. I'm hungry. I might still make a dedicated power bank, but I think I'm going to make that the BT one, the one that takes 2 of these batteries and 4 of those boards. So I can theoretically do 4 22.5 watt outputs all at the same time. I just think that would be nice. Yeah. Because I mean, while it would be nice to have 100-watt PD, need it. If I really want 100 watts, I got plenty of other batteries that'll do 100 watts. 22.5 watts is enough for 99.9% of everything out there. And even stuff that can, I mean, about the only thing I have that can use 100 watts is like recharging my tool batteries. And I'm not going to use something like this to recharge a tool battery. So for something like that, yeah, and I think I'm going to make that one 100% TPU. I'm going to all TPU on that one. So I want it to be durable. There's 2 of these batteries in it. About 40 amp hours or 128 watt hours of power. Does it? Oh yeah, I guess they do. Oh yeah, that color. It's like a psychedelic color forest. It's got all different tree colors. It's really cool. I love finding shirts on Temu. It's great. Um, my goals for 2026: double my income. So right now I'm making about $400 a month. I'd like to double that to $800 a month. That would I'd be a lot more comfortable at 800 bucks a month. I'd like to lose 50 or 60 pounds. I think that's feasible in 1 year. Um, I think that's enough for goals. I'd double my income from 400 to $800. Add 400 bucks to my income, and lose 50 or 60 pounds, or as many pounds as it's feasible for a person to lose in 1 year. Yep, that's my goals. That's why we're doing the stream on Tuesday, so I don't interfere with anybody's New Year's Eve. Figure people will be partying and whatnot, so next week we'll be back to Wednesday. Um, yeah, that's it. I'd also, I guess for this, I'd like to do 6 complete projects. That means, decent like this, a project from start to finish, published, ready to go. And try to get 6 good, decent published projects done. Not just a simple print, but something complex, something fun, nice, intricate. 6 good quality projects. I'm not sure how feasible that is. It's 1 every 2 months. Maybe go with 3 with a stretch goal of 4. Go with that. Yeah, I guess go from there. I got these new earrings you like. They're awesome. It's a little hoop, but it's got these 3 little fishies on it. I just think that's so damn cool. There it is. They're one of my favorites. I love those. I bought 20 more of these because they're so damn cheap. It was $5 for 20 of them. Um, I want to do more things with these just because I can run them directly off of this. Like for example, I'd like to make a ring of these in a fixture that you can hang up or put around. Because I'm already designing one to use these big ones. So I'm already working on one that's going to use a few of these, and that's going to run off of the tool batteries because those are 24 volts. It means I can run them right off of these 20-volt batteries. But I'd also like to make a smaller one that will run off of lithium iron phosphate battery. An area light that you can easily light up an entire room without a problem. And use 10 or 12 of these in a ring. I think that'd be pretty cool. I was thinking about designing it like a donut and then have a PETG sleeve that goes on top of it to diffuse the light. Although these aren't too bad to look at, they don't blind you, especially if you turn them down. You turn them down like this, you can look right at it, and it doesn't mess with your eyes too badly. Even just a little bit of diffusion for work. Yeah, these. Well, I don't know. These are a little cold for videography. It's not bad, but they're a little on the cold side. For any kind of photography or video, I would want to I would need these available in a different color temperature because the CRI on these is really bad. It's a pretty poor CRI. So if I can get these in warm white and then mix them like 2 cold white, 1 warm, 2 cold, 1 warm, 2. I usually do a 3-to-1 ratio. Um, that'll give me a pretty pleasant, warm, but not yellow, daylight white kind of light that has a relatively decent CRI. But these alone might not make a great selfie light. Just because the color rendition's pretty, it's pretty poor for photography. For seeing around the house, it's good enough. It's pretty clean light. It's decent light. It's not like green or yellow or blue. But for photography, I'm not sure. It's got a pretty cold cast to it for photography. I mean, not horrible, but also when I get up close, it's not so bad. Maybe with enough of them. But then again, maybe just putting a red filter in front of a couple of them might be enough to warm it up. So yeah, that might work. Maybe. Maybe. Um, I also want to make a tiny light. The trick is finding a viable BMS. I haven't found a usable BMS for it yet. It exists. I know it exists. I found listings for it. It's just sold out everywhere I go. It's a 21700 end cap BMS that's 1.2 amps or 2 amps. It's either 1.2 or 2 amps. I think it's 2 amps, which is pushing it. But a 18650 lithium iron phosphate cell should be able to handle that. That's stretching it, but with losses, I think it would handle it. So I want to make a tiny little flashlight, a pocketable flashlight that still uses this. Just one of these. So one of these in a super compact little form factor. Something about that big that uses a single 18650 cell. So it's not going to run for days like that one will, but it'll still run for several hours and be super compact. And I can make this smaller. You can trim this down. Yeah, there's room to trim this down. But I also want to do that, make a really tiny flashlight. But I wanted to use, I can do it easily right now using a regular 18650. They even make a USB-C socket that has a built-in BMS that you plug right into one of these. Super stupid compact. But that's not super long lasting. I want that lifespan of a lithium iron phosphate cell. So I'm still working on that. I might do an 18651 that uses the regular lithium polymer tenery chemistry just to do one, because most of the same design work should go into play. The only difference would be whatever the difference is in the BMS, or wherever that ends up fitting. I just haven't found too many. I found dedicated charge circuits. I found very small charge circuits, but no discharge protection circuits, meaning full BMS. That's just a dedicated charger with overvoltage protection, but it has no undervoltage protection, which means if you accidentally leave the flashlight on, you're probably going to kill that battery. So I don't know. I haven't found the. So the important thing is to especially, it's really important with something like this because it draws so little power. Even these two big lights on the top here, the full power ones, relative to this battery, they're drawing nothing. It's nothing. This is a couple watts. It's not even. It's a 3.2 volt battery, and we're not even drawing 3 watts out of it. And this one here is less than a watt. If you accidentally leave that on, it will drain this battery down to nothing. And you might not even notice that light dimming. That light might run down below 2 volts, at which point you're destroying this battery at that point. So the BMS has an undervoltage protection, where if the battery voltage gets down below a specific amount, it turns off. I have not found a viable 1S BMS for lithium iron phosphate for the smaller cells. We can get away with it with this cell because this cell can handle, 11 amps of input power. So even this 12 amp BMS is not overpowering this battery as far as what it's rated for. But I can't use, and I have a 3 amp BMS. That's what I'm going to get from now on, a 3 amp BMS. But I have not found. What I would need is one of two things. I would either need a 2 amp or smaller BMS, meaning that limits the charge to 2 amps or less, or I would need a lithium iron phosphate 18650 cell that can handle a 3 amp input. That's a lot. 3 amps at 5 volts. That's a 15 watt input to a single 18650 cell. Now, there are plenty of lithium ion cells that can handle that kind of input, but most of the lithium iron phosphate batteries I've seen typically want a 1C input. That's 3 watts, 4 watts. So even 2 amps is pushing it. Now, of course, I can fix that by going to 2 batteries. So a 2P configuration. And now the 3 amp BMS is only pushing 1.5 amps into each battery, which is still pushing it, but I think it would handle it. But now it's much bigger. It's not the tiny compact size I want. We'll see. It's just a matter of finding the part. If I can find the right part, going with the 21700 cell will probably be the best. because that's not that much bigger than an 18650. And it's a much better input rating. Hey, baby, how you doing? Yeah, I hear you. You're a good boy. You want to cuddle up? Yeah, they want to cuddle up. They're good boys. I found, like I said, I found the damn BMS, but it's not available. Yeah, I'll show you. Come on. Come on. 1S 3.22 amp. Here it is. So these are available, or well, theoretically they're available. I haven't found any yet. See, this goes down to 2 amps, but these aren't lithium iron phosphate. This one's lithium iron phosphate. Ooh. Here's another one. No, that's too big. Yeah, these are the high power ones. Here's the charge. This is charge only though. So there's no under voltage protection. So see, here it is. 3.7 volts, 2 amps. But I need this one. 3.2 volts. And they have a 2 amp right there, 2 amps. But it's not available. See how it's grayed out? So it's out of stock. See, sold out. And nobody seems to stock it. That's 3.7, 3.7, 3.2, 4.5 amps, but that's too much power. Is it just the extra MOSFETs? Like, if I buy this and I desolder that extra MOSFET, would that do it? Or would it still try to charge at the right power? Like, see how it's got spots for 3 MOSFETs? Looks like each of these is a certain amount of amperage. Like, could I just desolder them? I doubt it. Because I think the programming would have to be changed. Or it would still attempt to charge at the higher power and just blow itself apart. Okay, so here's the 1S 3.2, but this is 7 amps. That's too much power. Oh, wait a minute. Oh, what's this? 3. What's 2 MOS? Is this 2 amps? 3 MOSFETs, 4 MOSFETs. Is this fucking 2 amps? Certainly not paying that price. That's insane. I don't know. I think I need a single MOSFET. 1 MOS. Yeah, 2 amps looks like. That's pushing it, man. That's pushing a lot of power into a small battery. No, okay, so the 1 MOS, that's going to be the 2 amp. 1 MOS is the 2 MOS. So the question is, if I buy the 2 MOS and I remove one of the MOSFETs. Yeah, so it's 3 amps per MOSFET. That's backwards, I think. If I desolder one of the MOSFETs, will that give me the 2 amp one? Or will it still try to charge at 6 because it's programmed for it? like I'm asking for it to even think about trying it. I'm asking for trouble. What I really need is a 1 amp, a good, safe 1 amp. Like I think these do that. 2.4 amp. Either way, these should be safe, and they're cheap, but the problem is there's no undervolt protection. They're only $1 a piece, but this is only good for charging, not for discharging. And I need discharge protection. Damn it. I guess it's just so uncommon, I guess, for people to use single cell lithium iron phosphates that there's just not common circuitry available for it. Because I just haven't found one yet. There's plenty of them for 3.7 volt. This is the one I need, I think. I see 2 amp, 3 amp. So again, here, watch, I'll show you. But once again, the one I need. Yeah, there it is. There's the one I need. Right there. 3 amp, 2 amp. Sold out. Not available. Why? Why can't I get this goddamn circuit? And I've tried image searches, and everybody, it's the same thing. They have the 3.7 volt ones, but they don't have the 3.2 volt ones. Just nobody seems to carry the one for another one. Yeah, yep, there it is. These are the lithium iron phosphate ones. They're not available. Only the 4.5 amp. 2 amp 3.7, that's lithium ion polymer. 3.2 volts, that's lithium iron phosphate. 4.5 amp. Too much power. I can't push 4.5 amps into this battery. It'll kill it. Well, this one will handle it. This would work for this flashlight, but it won't work for a single 18650 cell. Let's see if I never did a search for 1 amp. I don't need a balance board. And here it is, but again, the smallest is 6 amps. This is charge only. This is charge only. Too high a power. Well, if anybody finds one, let me know. Ideally, a 1S, something like this, where you could buy 100 of them for 30 or 40 bucks. Either something that fits on the end of the battery or something like this. Like here, this one here is 15 bucks. Yeah, $21 for 100 of them. I mean, that's what, 20 cents a piece. But it's, well, that's 2.5 amps. That's not horrible. Ooh, I didn't notice that. But that one's a 2.5 amp. 20 is the sweet spot. Is that Damn shipping charge. I'm gonna save this. Let's see. I think for a 21700 cell, I think 2.5 amp would probably be okay. But for an 18650 cell, I think that's too much. Let's see, 21700, 3.2 volt. Are there even any available? I was having trouble finding 21700s. The 3.7 is lithium ion, not lithium iron. This might be 21700s inside, but I'm not going to dismantle a battery. Yeah, see, this is 21700 cells. So the goddamn cells are available. Well, it's lithium ion anyway. It's the wrong chemistry. There's a 26700. It's not too bad. 4 amps. It's a bit more than I wanted because it's going to be relatively large, but that's not bad. What's its limitations? So it wants half C, so it wants 2 amps, which means the 2.5 amp accounting for losses would be fine. This would handle the 2.5 amps. 4 amp hours is nice, but it's now we're getting large though. It's not a tiny battery. This is like 30 by 70. That's a high price though. Boy, they don't give you any discount either. Well, that's $5 each. 8 of them. Oh, now we're $4.50 a piece. $4 a piece. So you can get them for $4 a piece if you order 16. I guess the sweet spot in. Oof. I think I'll buy just 2. I'll keep an eye on it. I'm still surprised there's no 21700s available as naked cells. 45 amp hour. Woo! Wait a minute, what the hell's 2.3 volt? Oh, titanite. Okay, different chemistry. Those are 18650s. See, 18650s are available cheap. You buy them really pretty cheap. So what was that one? 26700? That's bullshit. They're just lying through their teeth. You can't fit 9800 milliamps in that space. I even question whether these can actually hold 4 amps. That seems like a lot to me. These are not choice, which means there's a shipping charge. Oh, free shipping. Well, that's not so bad. For 4 of them? Or is that just a charger? Oh, is it just a charger that you get that? Bastard. Really? The charger's $13. I hate that. I hate that so much. They should not be allowed to do that. They should be required to show the price for the picture. God, I hate that so much. That's $4 a sell. That's a little bit cheaper, but I don't want to spend that kind of money. How do you get open? That is so annoying. That's a little cheaper. $31. And it's a 2C output, but what's the input? Oh, yeah. Project Farm rocks. Does not say what the charge limits are. Why the hell won't you say what the charge limits are? That's kind of important. It does not say what the charge current limit is. It's like they're going out of their way to avoid saying it. Because it should be right here. Charging voltage 3.65 volts. Well, what's the fucking amperage? I'll add it to the list anyway, because that is not a bad price. Nope, I don't want to delete anything. What can I whack? Whack that. I'd still prefer to go 18650, even though it won't run as long. Just because they're available and they're cheap. See? I see 4 of them for $17. You can even buy them from Amazon. I'm gonna get some of these next time though. I like the 2 point. Go away. Good price and oh, I didn't check the pads. Where's the output? Is it on the bottom? I need to see the bottom. Where is the power output? There's battery input, but if it doesn't have a separate output, then it's not a true BMS. It's probably on the underside. It's probably just on the other side. Yeah, see, here's a charge. Here's a perfect. This is 1 amp charge module. The dedicated lithium iron phosphate charging module. It's perfect. Except for the fact that It has no discharge protection. It's not a BMS. It's a dedicated charging circuit. Just don't get why it's not available. Although what's interesting is you can already get sodium ion, which is even better than lithium iron phosphate. Higher power density and greater charge cycle. So here's a 20 amp hour sodium ion battery. I was actually thinking about grabbing one for the flashlight, but the problem is no charging circuits are available for it yet. 28 bucks for one, 48 bucks for two. They're a little expensive. Yeah, see, the voltages are different. It's 3.9 to 1.5, which means the lithium iron phosphate charge BMS would work. You just wouldn't be able to charge it to 100%, and you wouldn't be able to discharge it to 100%. But it is inside of that range. So if I find a cheap sodium ion battery, I might try it. Yeah, if I find an affordable one, I might try it, just because even though I won't be able to access 100% of its capacity, a lithium iron phosphate BMS will work. I find that hard to believe. I wonder if those are fake. I wonder if people are making fake sodium ion batteries. I wouldn't put it past them. I mean, who would bother to make an 18650 cell at sodium ion? Who would bother to make that? There's no application for it. There's currently no application for it. It's an awfully low capacity too. Yeah, I don't know about this. Maybe it is real. I mean, theoretically, they're easier to make. Hmm. Huh. I do want to try one of these days. All right. I want to eat that. Oh man, I want to get out of here. Make something to eat. Project Farm is great. His voice is a little annoying. He's got that high pitched, whiny voice that makes me want to punch him in the face. But his content is so damn good. He puts so much work into those videos. Holy shit. I don't think I've seen a video from him yet that I don't like. You know, you want to throttle him, but then again, you want to love him too. He just does such, he just does such a good job. I'm actually going to get more than $100 from Amazon this month. I got $51 from Amazon last month. That hurt. Yeah, I'm going to get $120. Oh yeah. All right, that's it. I will see you guys later. There's my kitties. They're all curled up. My kitties are all curled up. Yeah. Hi, kitties. Hi, babies. He's like, leave me alone. I'm sleeping. All right. That's it. I'll see you guys next week. See you next Wednesday. Don't forget, join my Patreon. Send me a PayPal. Send me a coffee. I got one of those coffee link things. Send me a Zelle, whatever you want to do. I appreciate it. All the money I make from you guys. So I will see you guys later.